Okay, class. Today we are going to look at lesson 35, which is solving quadratic equations 1. It will be the first of a two-part kind of lesson. Going right into it. Our warm-up. The vocabulary, a parabola is a graph of a blank function. So we should know that that would be a quadratic. Remember, a quadratic function is any function that has x squared, where the highest power is x squared, would make that a quadratic function. For the second one, if we were to factor 8x squared plus 4x completely, remember we are asking ourselves, what would we be able to take out of both of those terms? So the largest number that I would be able to take out is a 4. And then I would also be able to take an x out of both of them as well. So we would have 4x on the outside. And then on the inside, we would say if I took a 4x out, we'd be left with a 2x. And then that would be a plus 1. So if we were to distribute that back in, it would look like what we started with. And then the second one, a little bit more tricky here. Factor down 16x minus 20x minus 6. So you have to ask yourselves a couple different questions because we have to multiply our first two terms if we were thinking of FOIL, and it has to multiply to get 16. We have to multiply our last two terms and it has to get negative 6. But when we add those together, we need a negative 20. So you might have to try a couple things if you were doing a problem like this. What this one will end up being is we'll have an 8x and a 2x. So that'll get us to that 16x squared. And then if I'm multiplying to get a negative 3, we're going to need either a negative 2 and a positive 3 or a negative 3 and a positive 2. So we're using that middle term to kind of figure out which combination that it'll be. Now, I know that I am going to have to multiply this 8 by something, so I'm thinking what's going to get me closer to that negative 20? And that number would be as if I multiplied that by a negative 3, and then by elimination this would have to be a positive 2 right there. So just to double check, if we were to FOIL this out, we would get 16x squared minus 24x. The inside would be plus 4x, and then in the very end, last, would be negative 6. So this part right here simplifies down to that negative 20x. And like I said, you might not get it on your first try. You might have to try a couple of different things, but that's totally fine. All right, our new concept. Every quadratic function can be written in the standard form f of x is equal to ax squared plus bx plus c, where a cannot be 0. If a were 0, then it wouldn't be a quadratic function anymore because our highest power would be x and that would make it linear. To find the zeros of a quadratic function, solve the related equation ax squared plus bx plus c equals 0. So if you set that equal to 0 and factor it down, that will give us our solutions to our zeros. Many quadratic equations can be solved by factoring and applying the zero product property. So that zero product property, let a and b be real numbers. If a times b is equal to 0, then either a is equal to 0 or b is equal to 0. All right. This first one, find the zeros of our quadratic function. So if we have this piece as our function, again, we're going to set that equal to 0. That's a weird 5. And we can factor this down. We can't take a 4 out, or we can't take a 2 out because of that 25. However, this is a difference of squares because 4x squared is a perfect square and 25 is a perfect square. So we could actually factor this down to 2x minus 5 and 2x plus 5. Now both of these would be set equal to 0, and then in order to find the zeros we simply solve. So we kind of break it up into two different problems. 2x minus 5 equals 0, and 2x plus 5 equals 0. On both of them, we'll deal with that 5 first. So over here, I'm going to add 5, and that would give me 2x equals positive 5, and divide by 2. Then on the other side, I would subtract that 5 from both sides. So I get 2x equals negative 5, and then we'll divide by 2 there. So my zeros for this problem would be 5 halves and negative 5 halves. For the second one, we can't factor that down like we did this one. It's not a difference of squares or a trinomial or anything like that. So the most that we would be able to do is to take an x out. So what that'll then look like is, I'm going to say 2x squared plus x equals 0. And then if I factored an x out, we would be left with 2x plus 1 equals 0. So again, we would set both of these things equal to 0. I would set x equals 0, and then I would say 2x plus 1 equals 0. So over here, I will subtract 1. 2x equals negative 1, and divide by 2. So my second 0 term here is negative 1/2. Okay, so different ways of factoring different looking functions. Next, if we are to find the roots, if you'll notice, our function or our problem here doesn't look like it's in standard form. So the first thing we have to do is make it so it is in standard form. So what I'm going to do there is I'm going to add this 2x, and I'm going to subtract 15 from this side and add them over here and subtract 15. So what that'll look like then is we'll have x squared plus 2x minus 15. Now on that right side, since we got rid of both of those, that's just equal to 0. Now again, we ask ourselves, what is going to multiply to get negative 15, but will add up to get a positive 2, since this is a trinomial. So this one we will factor down into two binomial terms set equal to 0. So again, since it's just the x squared, that'll break down into x and x. If we're thinking of some factors of negative 15, 3 and 5 probably pop up pretty quick. So if I want a negative 15, and that middle term is going to be positive, our bigger number out of those two is going to be the positive one. So that'll be x plus 5 and x minus 3. So then again, we would set both of these equal to 0. X minus 3 equals 0. X plus 5 equals 0. And add 3. So x equals 3. And then subtract 5. So x equals negative 5. Those are our two different terms there. Okay, now each 0 is where the graph crosses our x-axis. So there are three different options. We can either have no zeros, like this first option here, where our graph is simply above the x-axis. We could have 1 0, which means that the vertex is actually on the x-axis, or we can have 2 zeros, and that would just be where it crosses either in any two places. Okay, I'm actually going to leave this one for you guys to do, comparing roots, zeros, and x-intercepts. A little bit of a spoiler, they're all the same thing. So the process in finding them is the same. We factor things down and set them equal to 0. Regardless of what it is, if we're dealing with a quadratic, the roots, the zeros, and the x-intercepts are all asking for the same thing. It's just different ways of saying them. So then I'll also have you try this one as well. This one is factored down a little bit differently, but I'll have you, again, check this one out on your own. The last one, or second to last one before we jump into the application, if we have the zeros of negative 5/3 and 1, that means we would have x equals negative 5/3 and x equals 1. So I want to know what the quadratic function for this would actually be. So I want both of these equal to 0. Now this negative 5/3, this is going to be a little bit counterintuitive. Hold on here. So this is going to be one of my factored terms that I will FOIL out again. But since I have a fraction here, I'm actually going to multiply by 3. And then I'm going to add the 5. So over here I'm going to have 3x. And then I'm going to add 5, add 5. So it'll be 3x plus 5 will be my other term. If I do that first, it's going to save me a little bit of trouble in the long run. So what I'm going to do with these two things is I'm going to FOIL them out. If I FOIL them out, that'll give me a quadratic function that would have those two zeros. So we have 3x plus 5, and we have x minus 1. So that'll give me 3x squared, negative 3x, positive 5x, and negative 5. Simplify, that will give us 3x squared plus 2x minus 5. So this will be your quadratic function then. Okay, last problem here. Dealing with vertical motion. The height of a free-falling object is given by the function h of t is equal to negative 16t squared plus an initial velocity times t plus an initial height. Initial velocity is in feet per second, height is in feet, and h of t is in height in feet at time t seconds. How long does it take an object to hit the ground after it is thrown straight down at a speed of 20 feet per second from a height of 84 feet? So we're going to have h of t, I'm going to plug that stuff in here, equals negative 16t squared. I'm going to say minus 20 because we're throwing it down, plus 84. Now, I'm going to factor out a negative 4 just to make my numbers a little nicer. So that'll be 4t squared plus 5t, and then that'll be minus 21 since I took out a negative. Then I'm going to factor that down like I would any other. Now again, this might take a little bit of time like that one in the beginning, but the way that you'll factor this one down is you'll start with a 4t on one side and a t on the other so we can get that 4t squared. Now, factors we have to multiply by are going to be add up or multiply to get negative 21. So the ones that kind of jump out right away should be 7 and 3. So that is actually going to be a minus 7 over here and a plus 3. So again, if that takes a little bit more time to get to, don't worry about it. I'm just doing this for time's sake in the video. So we set both of these equal to 0. This one over here would give me t equals negative 3, which doesn't make sense in context of the problem. So our answer is going to be 4t minus 7 equals 0. We will add 7, and divide by 4. So t is equal to 7/4 seconds. That's all I have today. Make sure you guys get your homework done. You can get that on the notes that are on Schoology. And have a great day.